So, please do these limits as a warm-up, and then continue with the video. For the first one, it's actually quite easy. Since you are allowed to put pi over 2 into sign without causing an issue, you can just plug it in and you're going to find that the limit equals 0 for number 1. For number 2, there's a problem. You can't just plug in number 8 because then your denominator would be 0. That's a little bit of an issue. So what I will do is multiply the top and bottom by square root of x plus 1 and then plus 3, because I'm hoping that the top will end up being x minus 8, which will cancel out the bottom x minus 8. That way I can actually plug in 8. So let's see what happens. So after multiplying the top, you end up with x plus 1 minus 9, which ends up being x minus 8, which allows you to cancel out the x minus 8 on the bottom and the x minus 8 on the top, leaving you with the limit of 1 over the square root of x plus 1 plus 3 as the limit approaches 8. When you plug an 8 in there, which you're totally allowed to do, you end up with 1 over 6, because the square root of 9 is 3. For the third problem, this one, can we plug in 6? When you plug in 6 on the bottom, it's going to be 36 minus 24, which is 12, and then 12 minus 12 is 0. So we cannot plug in 6, so let's factor some stuff. Now we're kind of lucky because the bottom ended up having x minus 6, so the x minus 6's will cancel, leaving you with a limit of 1 over x plus 2. When you plug in 6, you're going to end up with 1 over 8. That's your answer. Let's continue. In today's lesson, we're going to be learning derivatives, or we're going to review derivatives, because you should have started derivatives. It's a really hard word for me to say. Nice. All right. It's a really hard word for me to say, but we're going to be reviewing derivatives. So let's get started. A derivative is a rate of change. It is very often the slope at a given point. So for a line, the derivative will never change. So if you have a line, the slope is always constant, which might in this case be 1 or 3 over 2, who knows? Or 2 over 3. Any one of those, any positive slope. But when it comes to a function that has curves, then we know that the slope here and the slope here, they're all different. So very often we rely on an expression that allows us to find the slope of the tangent line at any given point of a curve like this. So let's do that bad boy. All right, let's continue. So to talk about derivatives, let's talk about where we got the derivatives from. In this case, let's say we have a graph, x cubed minus 6x plus 2, and we want to know what the slope would be of a tangent line at 1 comma negative 3. Or just the slope or derivative at that point. Well, when you start making estimations, when you start to look at 2 points and just find the slope using the slope formula, you can tell that the line is not very similar, that you're going to get the slope for the line. It's not going to be similar to the tangent line at that given point. So the best way to do this is to just start approaching the 2 points. Get as close as you can, and actually get infinitively close. So if you want to do the slope formula and just kind of find out the best way to find the tangent slope, we want to be infinitively close. So if h is a distance between those 2 points, we want to find the limit as h, the distance between those 2 points, approaches 0, which is why you ended up with the following equation. The limit of f of x plus h minus f of x divided by h. If you ever wondered why that represents your derivative, it's because it comes from the slope formula. This right here could be considered y2 minus y1, and then on the bottom, this would be x2 minus x1. So it's a slope formula where we just attached a limit to it. Also, I want to make sure I'm careful when I say what h represents. H is a distance horizontally. It's the distance on the x-axis. So how far is x2 from x1 away? That would be h. So again, here's your definition of the derivative. So let's try an example. Find the derivative of x squared plus 1 using the definition of derivative. Then find the slope at the points -1, 2, and 2, 5. Try that out. So the first thing we do is write down the definition of a derivative. And we start plugging in where we can. So when it says f of x plus h, you simply plug in x plus h, where it says x squared plus 1. So we're going to end up with x plus h squared plus 1, and plug it in like we did over here. And then we just subtract from it x squared plus 1. So in this case, we're going to have to do a little bit of foiling. And you end up with this right here. And you cancel out what you can. Every time, you should be able to end up with an expression that has a factor of h in it. And the reason why you do is because the h's will cancel, leaving you with an expression where you can simply plug in h equals 0 and giving you the derivative of 2x. So the derivative of x will be 2x. When you plug in the -1, because we're talking about these points right here, when you plug in x equals -1, then you can find out what the derivative is at x equals -1. So in this case, at -1, 2, your slope for the tangent line should be -2. So the slope would be -2. And then for 2, 5, your slope for that tangent line at that point will be 4. So that's a drastic difference. You pretty much at that line, you can tell that you have something that was kind of going down, and then drastically at 2, well, it might have happened gradually. I don't know what happens between -1 and 2. There was a big increase where the slope is suddenly 4. Alrighty, let's continue. Try out this example. Find the derivative, then find the slope at the point 1, 1. We start off with writing down the definition of derivatives and plug in. Now, you can't just plug in h, so what do? We multiply by square root of x plus h plus square root of x. Hopefully the top, the x will cancel, and we can cancel out the h on the bottom. So let's try that out. So when doing this, we're going to end up with x plus h minus x, and I'm going to go ahead and write that down for you. So in this case, we will see that the x's will cancel, and so will the h, because we have an h now on top and an h on the bottom, so let's cancel these as well. And we are left with the following. So the question is, can I now plug in 0? And the answer is yes. You're going to end up getting 1 over square root of x plus square root of x, which will end up being 1 over 2 square root of x. And that will be a derivative. F prime of x equals 1 over 2 square root of x. Now we can plug in for the point 1, 1. When you plug in 1, your derivative at x equals 1, let's put that down, is 1 over 2 times 1, which is 1/2. The derivative is 1/2. Find the derivative, then find the slope at the point 1, 1, and 4, 2. Sorry, I didn't see that one. So the slope at 4, x equals 4, will be 1 over 2 times 2, which is 1/4. Alrighty, and that's how you do this problem. What about the power rule? There are obviously shortcuts to do the derivative, and you probably knew about them before we started this lesson. The power rule allows you to find a derivative without using a limit. In this case, the way that works is you look at the power of each polynomial. So the first one is x squared plus 1 x to the 0. So in this case, we grab the power and we attach it to the front. So we multiply to the front. So in this case, 1 times 0, and over here we have 1 times 2. So when you do that, the powers reduce by 1. Now, I know you're probably wondering, well, when you reduce 1 from 0, you're going to get -1. That's going to cause a problem, but that doesn't matter. This will just become 0 since you're multiplying 1 times 0. So that goes away. So over here, we have 2 going in front. So it's going to be 2x, and x, the new power will be 1. So it's going to be 2x. That's going to be the new one. So why don't you go ahead and try using that method to find these ones as well. Good luck. Alrighty, at this point, I'm going to go ahead and reveal all the answers. For this one, you should have gotten 6x minus 2. That's because 3x squared, you attach the 3 to the front, 3 times 2 is 6, and then the x squared becomes x, and then you have minus 2 because x to the 1 reduced becomes 0, so x to 0 is 1, and you also 2 times 1 is just 2. The next one, and you're going to get really good at this towards the end. Every time you have like a number, those things will always end up going to 0 for the reason I mentioned over here. So over here, we're going to have this part's going to end up giving you 2x, and that's going to end up giving you -8. And then for the last one, that's going to be 3x squared plus 3. And that's for your derivatives. All right, let's move on. See if you can do this one, the power rule. Find the derivative of f of x equals 3x squared minus 2x. After you do that, find the slopes at those 2 points given. Pause the video, and I'm going to reveal the answers in a moment. So, using the power rule, I found the derivative to be 6x minus 2. To find the derivative at -1 and 2, I just simply plug those two numbers in, because you're only working with the x coordinates of the points, not the y coordinates. And you end up getting at 2, x at the point 2, 8, the derivative is, or slope, is going to be 10. And at -1, the slope is going to be -8. Again, a very drastic change between the 2 points. And as far as the x coordinate, those points were only 3 away. Let's move on. Now, what happens when you have a radical? When you have a radical, I want you to see if you can switch it up a little bit so it becomes a power, so the power is more visible. See if you guys can figure that out. So pause the video, play with this, and see if you can get the answer. Alrighty, so we're going to end up getting x minus 1 to the 1/2 power. The 1/2 implies radical, or square root. So when you do that, finding the derivative is going to be a lot easier. So to find the derivative, we multiply the front by the power, which is 1/2. And then the inside remains the same. Good thing this is not a chain rule yet that we have to worry about. And when you do 1/2 minus 1, you're going to end up with -1/2. So if you were to rewrite it, it will look something like this. 1 over 2 times the square root of x minus 1. And then you plug in 2 and 5 to get the slopes. I'll let you guys go ahead and do that. I'm pretty sure you guys by now don't want me baby feeding you these answers. So continue. Now in this case, you want to find derivative of a rational function. You want to find something with a negative exponent. So if I was to rewrite this, how would you rewrite it to apply the power rule? Pause the video and give it a try. So when you rewrite it like this, where it's x plus 5 to -1, you're going to end up with -1 times x plus 5 to the -2 power, which when you rewrite it, is going to be negative and then 1 over x plus 5 squared. At this point, I'm actually satisfied with this. I know in college they might ask you to FOIL the bottom expression. I never like to FOIL because sometimes being factored is just the way you want to be. I never understood why my professors asked me to FOIL something that later on I might have to factor. Anyways, so that's how you would do this. Boom.